Here we're going to learn how to find the domain of the function in two different ways. One is algebraically, the other one is graphically. Now we're going to start out with algebraic approach to find the domain of the function, since we just went over 4 different type of function. We have evaluation, we started out with the polynomial functions, and then we move on to the cube root functions. Even square root function also can be called as even index radical, and then last but not least, the rational function. And we, after evaluating those functions, when they're given us some input, we also talk about the domain, right? So let's go ahead and this is the algebraic approach to find the domain of function. Now we can actually easily to categorize those 4 functions into 3 categories. The first one, I'm going to start out with the even index radical. For even index radical function, we will set the radicand. Remember that? Radicand. What do we do with the radicand? Because it is even index radical, so you won't want to make sure that underneath the even index radical sign, there's no negative number. So it's greater than or equal to 0. After you set out this inequality, and you will solve for x and solve. All right? And the next one will be, let me think. Another one we actually did something about it was the rational function, right? For rational function, remember what we did? Because for the rational function, there are variables in the denominator. And in math, we cannot divide by 0. So we will set the denominator. That's where the problem is the denominator. When you have equal to 0, because when you have the variable in the denominator, that will change whenever you put a different x value, that there will be a chance, there might be a chance that will make the denominator equal to 0. So we set that equal to 0 and solve. All right, so then what happened? Remember, we have 2 other functions that they have a domain of a real number. And those other function is they are not a rational function, and they are not even index radical. So, and there are actually other functions that has a domain of a real number. So what we're gonna say right here, it will be for all other functions. Instead, list all the functions that you have a domain of a real number. Now we're just gonna list the 2 that we have to actually solve algebraically, which is the even index radical functions and a rational function. All the other one, for all other function, the domain is a real number. Oops, let me use this one. Negative infinity to positive infinity. Okay? That's pretty easy to remember, right? So so that's the first thing you do is be able to recognize what type of function that is given to you. Once you know what the functions are, what type of function they are, and then you just follow the rules, right? So there's only 2 things you have to do. When you see the even index radical, you set a radicand greater than or equal to 0. When you see the rational function, you look for the denominator, and you need to know how to recognize the rational function. And you look for the denominator, you set it equal to 0, and you solve. And there is another one. There's another one that we'll talk about later when we're doing on the homework questions, or maybe the practice, is when you have an even index radical functions in the denominator. We'll talk about that in a little bit, okay? And but other than that, all the other function, the domain is just a real number from negative infinity to positive infinity with parentheses. So let's go ahead and practice with the actual questions. The first question, part A, f of x equal x plus 5 over 2x squared plus 5x minus 12. Now this looks really obvious that is a rational function, right? Now, if you still need some reminder of why this is a rational function, I would suggest you to write it out. This is a rational function. Why? Because there are variables in the denominator. And if you, hold on one second. If you say that to yourself a couple times, when you see the questions, different questions, and then they all randomly assigned to you, and then you tell yourself why it's a rational function. Don't go so quick just every time when you see a fraction bar, and then you just say that's a rational function, okay? The actual definition of rational function is when you have a variables in the denominator, and we do. Right, so the denominator, so that means that we don't have to worry about the numerator, okay? Only focus on the denominator when you have a rational function. Now I've recognized this is a rational function, so what do? We'll follow the rules. The rules right here. The second one, right? It tells us to set the denominator equal to 0. So my denominator is 2x squared plus 5x minus 12, and set that equal to 0. Do I have to worry about the numerator? No. Okay, if you go back to the notes we have, last one, it's okay to have a 0 on top. So for example, this 92, when you put into the rational function here, it gave me 0 on the numerator. It's not affecting the ability this is answer. The answer is good, it's a real number. Is when the 0 is on the bottom that we have to throw it out because it does not exist. So we try to find such a number that will make the denominator equal to 0, right? And I did that. The next thing is to solve. So that goes back to what we practiced in the first module, solving equations. And this is a trinomial. And not just any trinomial. It's a trinomial that have the coefficient of x squared is not equal to 1. And I mentioned that before that this many students have difficulty to factor the trinomial when the coefficient of x squared is not 1. Okay, and please, if you are one of the student who have struggled through with this, make sure you utilize the resources I provide on Canvas to practice that. Okay, now I've done one of the questions like this that the coefficient is not of x squared is not 1. But that time, I can actually factor out that coefficient. Remember that I factored out 2, and then make the x squared have a coefficient of 1. This time, I don't. There's no common factors. So I will have to just go ahead and factor this one. And then the way that I do is I use the backward foils. Backward foils. Foil, F-O-I-L. Okay, backward foil. So the first is the 2x times x will give a 2x squared. We'll do backwards, right? Then when you're thinking about the factors of 12, 1 and 12, 2 and 6, 3 and 4. This is the tricky part because we can't be sensitive. A coefficient of x squared is not 1. I can't just say, oh, I need to find the one of the pair, add and subtract equal to 5. In fact, none of them will make that happen, right? But because we're doing the foil, backward foil, so we're actually going to find the pair that when we do the OIT, O and I, will give us a 5, okay? So it takes down trial and error. After I try a couple possibilities, I won't try 1 and 12. I probably try 2 and 6 or 3 and 4. But I think I'm going to try 3 and 4. 3 and 4. 3 times 4 is 12. And then the most important thing is right here. All right? Is the OIT. Or is the outer. OIT. I is the inner. 2 times 4, I think I meant to put positive 4 right here. That's 8x. Negative 3 times x is negative 3x. And that gives us 5x, right? So, and then negative 3 times 4 is negative 12. So that's a correct factors here. So this, the only thing is going to different between this type of trinomial and the one that you have x squared with the coefficients 1 is it just takes a little bit more trial and error to get to the correct one. And just be patient, all right? So once I find out this is the correct one, we're gonna solve each factors with x equal to 0, right? So I'm just go ahead and write right here. I have 2x minus 3 equals 0, x equals 3/2, x plus 4 equals 0, x equal -4. Okay, so what happened here is in the entire real numbers systems, or I'll look at the real number line, there are two numbers that we shouldn't have. It shouldn't be in the domain. The two number we just found, one is -4 and one is 3/2 or 1.5. What happened to those two numbers is if you plugging into the functions, the top will be fine, the numerator, once it has a numerator, like 84 plus 5 is just 1. But when you plug in 84 on the denominator, it will be 0. It will be 0. So we cannot have this number in. And remember what we did earlier? You can either put a circle around this two number, you can put the x's around number. So now it started out with just one segment, one long segment of infinity, negative infinity to positive infinity. But now what happened is we had to break out this one long segment into 3 subinterval. Okay, why 3? Because the two numbers that we don't want. Okay, so you can see on the graph I draw right here is a one long line segment got cut into 3 different intervals by two numbers, right? Earlier we have a question that has a one number we don't want and divide that into 2 subinterval, but this time we have 3. And all you have to do is read from left to right. So you have 3 intervals. So the domain here is, there's in the interval notation will be negative infinity to -4. Remember, it's all parentheses, union or comma, -4, comma 3/2, union or comma 3/2 to positive infinity. Okay, so if you know how to draw your number line to put this number on the number line, the number that you solve, your answer is standing out in front of you. You put the negative infinity on the left, put the infinity on the right, and just write your answer down from left to right with all parentheses. All right. What about set builder notation? Okay, x such that x not equal 3/2 and 84. It's similar to what we had earlier. X such that x is not equal to 1. Whatever the number that we saw from the denominator expression or equations, that's the number that is or are the number that we do not want included in our domain. So there you have it right here. So again, you have to make sure you know how to solve equations. You're gonna see quite a few questions like this asking you to find the domain of a rational function, and then you want to make sure that you know how to solve the denominator. Okay. All right, so next question, part B, 2x squared plus 1 over 5 minus x. Now, is this a rational function? And I see most of you are going to say yes, right? And if you say yes, you're correct, because we have x in the denominator. It's not how many. So you have one x, one variable. Don't have to have too many x. You have to have a long one, a expression with many terms. No, you just need to have a variable in the denominator. Then we will consider rational functions. Okay, so this rational function, the denominator looks very clean, just 5 minus x, and that's all we have to do. So a and b really, you have to think about them are the same type of questions. When I say same type of question is the approach that you go through this question to get a correct answer is very, very similar. As at least the concept is identical. Okay, you recognize that this is a rational function, and then you identify the denominator and set it equal to 0. So the only difference is the solving part. Now, yes, we will say the solving part for the second question is much easier than the first one. But you know what? If you learn and you master how to solve algebra equation, then the first question will not seem too difficult. So make sure that your first module you're doing very well on first module. So here we don't do any different special things about getting x by itself, x equal to 5. Then this time we only have one numbers that we don't need on the number line. I like to draw my number line, and so just like I said, very, very visual for me to see. Remember I say you draw the number line, put the number that you solve on the number line, and you write negative infinity on the left and infinity on the right, and your answer is right there. You're writing your answer by looking at the graph and from left to right. Negative infinity to 5, parentheses, comma, or union, 5 to positive infinity. Do you see? Negative infinity to 5 and 5 to positive infinity. We're not including. Remember, parentheses not including 5. And the set building notation is x such that x not equal to 5. So that's how we find the domain. Now, as for you doing the work, yes, you don't need to write all these things I write in orange, but that's helping. It's a class notes and help you to think through the process while you're studying it. And when you get very familiar with the concept, then this is in your head. The orange part is in your head. What kind of function is this and what should I do?